Students, Hari Om. Today we will we will learn about the circle. You have studied already in the previous classes circle and about its properties. So today we will start again. We will learn some basic things about the circles and its theorems. Circle. What is circle? Circle is, this is a circle. Now, according to the definition, the collection of all the points in plane which are at a fixed distance from a fixed point in the plane is called a circle. Means these points, we are discussing about these points, the collection of all the points in the plane. See, these are the points in a plane which are a fixed distance from a fixed point, and this is a fixed point. This one, you can see that. See here, this point, we are talking about this point, right? Now from all the points, this is from equal distance. Now you can see here, this is, now this is, there are many points in a plane, right? And this is a one point, this is from equal, from fixed distance from a fixed point in a plane is called a circle, right? Now next is, we will discuss what the parts of the circle. This is, first one is radius, diameter, center, chord, arc and the sector, because these are very important to understand the circle, right? Now if we don't know these parts, so how to understand the circle? Now how to understand the theorems of the circles, right? Now what is radius? First we will discuss, you know very well, you have studied in the from the third class, right? Now the line segment joining the center and any point on the circle is called a radius of the circle, right? See here, now we are talking about this one. This is here, this is, now this is the point, we are talking about this one. Now this is a center, this one, this is a center and this is a point on a plane, right? Now this when we join these 2 points, then it is called radius. Now it is center, this is a radius. Radius is, means the length of all the radii of a circle is equal length, r of equal length. Now see here, from all the points this length is equal, right? Now this is a radius. A diameter is the 2 times of the radius. Now radius and the diameter is the 2 times, means we have to see here this one, the line segment which pass through the radius, which pass through the center of the circle is called the diameter. Now this is, diameter is also the chord. Now chord is what? Now center is the fixed point is called the center of the circle. We are talking about this point. We are talking about this point. This is the center of the circle, and which is equidistant from the all the points. Those are like in a plane. Now, what is a chord? What is a chord? If we take 2 points on a circle, like it is written P and Q on a circle, then the line segment PQ is called a chord of the circle. For example, we are taking this point is P, this point is Q. So you can assume that this one is, this is a chord. This is a chord, and the chord, the length of the chords, there are infinite chords are there. There are infinite chords you can draw, and the length of the all chords are not same, right? A diameter is the longest chord of the circle. Next is a piece of circle between 2 points is called an arc. Means we are talking about the arc. We are talking about arc. Arc is what? This is the piece of the small part of the circle is called arc. See here, we are talking about this one. This is a complete circle. This one, complete circle is this. Now we are talking about this. This is an arc. This one, this is an arc. This is an arc. Now next is sector. We are talking about the sector, which is a very important part of the circle. This one is sector is this. Now this is a sector. This, look at it. This is a sector. Now Sector is what? The region between an arc. We are talking about this one. This arc. This is. And the two radii. Two radii is this. One is here. One is here. These are two radii are there. And this is one arc. This is one arc. The area or region between an arc and the two radii joining the center to the end points of the arc is called a sector, right? Now one more point, one more term is here, segment. There is segment. Now sector is also two types, minor segment and major segment. If we will talk about this one, this is a minor sector, and this one big one is major sector. Now next is segment. Segment is what? The area bounded by an arc and the an arc and the chord. An arc and the chord. If we will see here, this one. If we will talk about, this is ye. Now this one. If this is the center is this, and this is a chord, and we are talking about this one, this area. This is, that is AB. AB is a chord, and you can say that AB is an arc. So the area bounded by an arc and a chord is known as, that is, segment. This is known as segment. Now next is, today we will discuss only one theorem which is a very important. See, this one. We will discuss theorem 1. Theorem is what? Equal chords of a circle subtend equal angles at the center. Equal chords of a circle subtend equal angles at the center. See here. We will learn it practically. See here. These are two equal chords we are taking. First one is, this is one. This is the second one. These are two chords are there. We are talking, this is theorem, right? Theorem is what? Equal chords of a circle. These are two equal chords we are taking. That is, you can give the name AB and CD. Subtend equal angles at the center. Subtend means they are forming angles at the center. And where is the center? This is the center. Now this chord is make an angle, this one. Subtend angle, this one. And another chord, this is also subtended an angle at the center. And now we have to prove, means these angles are equal. These angles are equal. Means equal chords of a circle. Means these equal chords forming or subtending equal angles at the center. So to prove, that is, you can say that if you are naming the chords, that is AB and CD. So you can say the center is O. You can say that COD. You have to prove it equal to AOB. Now see how to prove. We will use, that is, the congruency. Means we are, by using congruency, we have to prove these two angles subtended by equal chords at the center are equal. Now see here, we are taking these two triangles. We are taking these two triangles, that is triangle AOB and COD. Now we have to see the similar equal parts are there. Now you can say that it is given AB is equal to CD. Here AB, see here, AB equal to CD. That is given in the question. Equal chords of a circle. That is given. Now next is, that is OB. OB is equal to, that is OD. See here, OB is equal to, that is OD. Means that is the radii, same radii of the circle, radii of the same circle. And the similarly OA is equal to OC. Now you can say that this is also radii of the circle. Now by using, see here it is a side, this is also side, this is also side. So by using triple S congruency criterion, you can prove it, these two triangles are congruent, right? That is, you can say that triangle AOB congruent to triangle COD, but you have to follow the order. right? Which part is the corresponding part of the other triangle. Now you triple S, we are using the congruency rule. Now from here, that is angle, we can see that angle AOB is equal to COD by CPCT. CPCT means corresponding parts of congruent triangles. If you have to prove if two triangles are congruent, then you can say that the corresponding parts of the congruent triangles are equal. So we are seeing here, this is angle AOB is equal to angle COD, that is CPCT. We can say that this angle, we are proving this one, these angles. These angles we are proving, this one. Now this is this angle AOB and angle COD we have to prove. This is theorem 1 in the class 9. So theorem is what? Equal chords of a circle subtend equal angles at the center. Now next theorem is that the converse of this theorem. That is the converse of this theorem. What is that theorem? If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Converse means what we have proved in the previous theorem, now that is given in the converse, right? See here it is given, we have to prove in the previous, that is chords. This, see, we have to prove in the previous theorem, that is theorem number 1, center are equal, right? Means if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. But in the previous theorem it is given. In the previous theorem, in the theorem number 1, it is given the chords are equal, means it is given that is AB is equal to CD. But here we have to prove it. We have to prove it in the converse. This is the converse. Theorem 2 is converse of the theorem 1. So in the same manner we can prove it. See here, this one. They are two chords but are not equal. It is not given. They are equal. We have to prove it, right? Now this is the angle subtended by this chord at the center of the circle. See here, it is this one. Now this is a chord AB. AB is a chord, CD is a chord, but these are not equal in length. But we have to prove these chords are equal. But it is given. What is given? Given is angle AOB is equal to angle COD. It is given. It is given in the theorem. The angles, if the angles subtended by the chords of a circle at the center are equal, then the chords are equal. So see here, these are not equal. So again, we are taking two triangles by using the congruency concept. We will prove these two triangles are congruent. Then we can say that by CBSE these two chords are equal. See here, similarly, this means you can say that OA is equal to OC. This one, these are radii of the same circle, and OB is equal to OD. That is also radii of the same circle, and it is given angle. This angle, you can label it angle 1, angle 2 in the figure. In the figure, you can label it. This is, if you want to see, this is we are taking these two chords here, but not equal in length. This is, they are subtended equal angle. So you can label it angle 1 and 2. This is angle A, B, C and D. See here, we have to prove here. We have to prove AB is equal to CD, and given is that is angle 1 is equal to angle 2. These things are given. right? So in the similarly, in the previous theorem, we have to prove this angle, this side equal to this side, means these are same radii. This is also same radii, and this angle 1 and angle 2 is equal to these are equal. So three statements we have to prove for congruency. And one, this is side, this is angle, and this is side. By using SAS, side angle side similarity criteria, these two triangles are congruent. Now we can say that chord AB is equal to chord CD by CPCT. That is, this is the theorem number 2, which is the converse of the theorem 1. Thank you, and we will continue with the same theorems in the next video. Thank you. Hariom.